गुड मॉर्निंग। ये हमारी एमएससी प्रीवियस ऑर्गेनिक केमिस्ट्री की क्लास है। रिएक्शन मैकेनिज्म में हम पढ़ रहे हैं रिएक्शन इंटरमीडिएट्स। रिएक्शन इंटरमीडिएट्स में वी हैव ऑलरेडी फिनिश्ड कार्बोकैटायन एंड कार्बोनाइन एंड लास्ट टर्न वी स्टार्टेड फ्री रेडिकल्स। फ्री रेडिकल्स में अब तक हमने पढ़ा कि व्हाट आर फ्री रेडिकल्स, हाउ दे आर फॉर्म्ड बाय होमोलिटिक फिशन, highly reactive species, their half-life period is very less, electron deficient species, they are odd electron species and hence paramagnetic in nature, formal charge on them is 0, and something peculiar was about their structure. The structure is that carbon having odd electron can be sp2 hybridized, can be sp3 depending upon situation. Particular situation you should remember, if formed at bridge head in bicyclic compound, then it is sp3 hybridized, and if strong electron withdrawing groups are attached to odd electron carbon or some very bulky groups are attached to this, then it is sp3 hybridized. I explained you how sp2 changes into sp3 and what are the reasons behind this. Okay, continue from that. This is what I revised, what we have studied so far. Today we will study about formation of free radicals. How free radicals are formed, what are the various conditions for the formation of free radicals. फ्री रेडिकल्स के फॉर्मेशन के लिए इम्पॉर्टेंट कंडीशंस क्या हैं और वो कैसे बनते हैं, इसके बारे में आज हम पढ़ते हैं। देखिए, सबसे इम्पॉर्टेंट, जब भी आपने फ्री रेडिकल की अब तक कोई भी रिएक्शन पढ़ी होगी तो आपने देखा होगा two important conditions for the formation of free radical are very high temperature and light. That is, temperature above 500 degrees centigrade and light is very essential for the formation of free radical. Under these conditions, homolytic fission takes place and free radicals are formed. But there are other modes of formation of free radicals. So just let me tell you what are the various conditions for the formation of free radicals. In general, we can say there are ways of forming free radicals, and for that I am writing it like this. It will be very easy for you to remember. Help, and then radical R, helper. बस ये ध्यान रखिए. Now here H, what does H means here? H means that is heat or temperature greater than 500 degrees Celsius. Now, if it is formed by this, the process is called thermolysis or pyrolysis. You know the meaning of pyro, you know the meaning of thermo at MSc. Need not explain this term. So then it is heat. E means in many reactions it is formed by electrolysis process. Say, many reactions are there in which it is formed during the electrolysis process. In some reaction it is formed by applying electric arc. L means light, and generally we write it like this, light, and when it is taking place by heating of light, the process is called photolysis. In such cases this process is called photolysis. Then, very important, in many reactions it is formed by the presence of peroxides. I'll explain you, I'll take examples of each and every type. Peroxides. Peroxide is very essential conditions for many reactions. We write like this, that this is a peroxide we have taken, and in presence of peroxide a free radical is formed. R means radical itself. Radical is there, then radical is a very good initiator of reaction, and radical will keep on propagating, and hence. But radical is formed from all these things. 4. So these are the 5 different ways through which a free radical is formed. Let us take example of one by one. Say, take the example of thermolysis or photolysis or pyrolysis. Okay. Now, say thermolysis pyrolysis or photolysis. We can combine these examples how free radical is formed. Commonly you must have seen, say we have a chlorine molecule and we are one condition is either light or temperature needed is above 500 degree centigrade. If it is so, what will happen? This bond will undergo homolytic fission, that is, this electron pair will be taken by this will be taken by this, and as a result of this, odd electron species is formed. Chlorine free radicals are formed in presence of this. Similarly, another example for this, by heat this light, say you have acid chloride. Say you have acid chloride is there. You have acid chloride, and if it is given light, again this bond, it will undergo homolytic fission, and as a result of homolytic fission, this kind of species are formed. One species will be this R O O O. Now this is odd electron species, and another odd electron species will be a chlorine free radical. This is again formed by this. Similarly, thus let us take some examples of peroxides. In many cases, free radical is formed by peroxides. For example, like in general we can represent it like this, R O O R. This is. Now you can see here why peroxide form easily. There is a repulsion between this, and this undergoes due to this homolytic fission. It takes up its own electron, this takes up its own electron, and as a result of this, what is the radical formed? Alkoxide free radical is formed. Two alkoxide free radicals are formed. Normally for this purpose we take benzoyl peroxide and like that. Similarly, there is one very specific free radical initiator, very good, and you can note down this example. This is very good example, and very reactive radical initiator is formed, and it is formed from azo bis isobutyronitrile. This is Bu. Azo bis isobutyronitrile. In short, it is called AIBN. Azo bis isobutyronitrile. Whenever this is there, जब कभी भी ये आ जाए आपके पास रिएक्टेंट में लिखा हुआ, आप समझ लीजिए कि पक्का ही फ्री रेडिकल बनने वाला. What is azo bis isobutyronitrile? I will tell you its structure. Its structure is like this. C N double bond C. This we will convert these into two. This is this azo isobutyro. This is, and here you will get nitrile, means here you will get the cyanide group here and cyanide group here. This is isobutyronitrile, azo bis isobutyronitrile. This is isobutyro and this is azo bis isobutyronitrile. Now what happens in this case is, see this and this and this. How electrons are taken in this case? This electron pair is taken by this electron pair comes to this electron pair is taken by this electron pair goes to this. So this odd electron will form nitrogen gas, and as a result two radicals will be formed. And what will be these two radicals formed after this? From this two radical formed will be minus तो हो जाएगा यहाँ से nitrogen gas, see, and nitrogen is formed, and from this we will get two radicals, and they will be this. Two highly reactive species like this are formed. So hence it is a very good radical initiator. Very good radical initiator. So this is a key example for the formation of free radicals. Okay. So you have seen peroxide, how it is formed by photolysis, how it is formed by this pyrolysis. Let us take one more example in which generally we get confused. Say we have benzoyl peroxide, and see why we are taking this example and what is the mistake we do in this. Benzoyl peroxide. See, this is your benzoyl peroxide, and benzoyl peroxide, like other peroxide, will undergo homolytic fission, and homolytic fission means this electron taken by this electron taken by this, and as a result of this, species formed will be this C double bond O odd electron over this, but be sure this is not the final, this is not the radical initiator. Why this? Because this bond will undergo further initiator. This will take electron, this odd electron, and this odd electron will form a double bond. As a result of this, from this carbon dioxide goes, and what we get is a phenyl free radical. आई होप ये बात आपको समझ में आई. जनरली हम क्या करते हैं, इसके अंदर इसी को फ्री रेडिकल मान लेते हैं, बेंजॉइल ऑक्साइड. नो, this undergoes homolytic fission, and actually the radical initiator in that is phenyl free radical is formed in this case. Now let us take some more example for the formation of free radical, how free radical is formed. I think all these steps are very clear to you. ये steps बहुत अच्छी तरह आपको समझ में आ गए हैं. अब हम देते हैं कि जैसे इलेक्ट्रोलाइसिस में कैसे बनता है. Let me change the page. How it is formed in electrolysis. Okay, let's take the next page. Next example देखते हैं कि how it is formed in the process of electrolysis. Say electrolysis. Now आपको ध्यान होगा इलेक्ट्रोलाइसिस में सबसे ज़्यादा कॉमन एग्जाम्पल क्या पढ़ते हैं, एक रिएक्शन पढ़ते हैं आप, कोलबे इलेक्ट्रोलाइसिस. तो इन व्हाट हैपन्स इन कोलबे इलेक्ट्रोलाइसिस, sodium or potassium salt are subjected to this. Now, in this case what we have is R C double bond O 2 2 4 1 5 N. This is and hence this is negative. This is the anion. Now this anion, anion will go at which electrode? Anion will go at anode. So this will get at anode. At anode what process takes place? At anode oxidation takes place. As a result of this oxidation means what will happen in this case? What will happen in this case will be, again see, this is this, it will take up, this will undergo further, this will give up one electron. After giving one electron, what we will get is R C double bond O and this plus electron. See, this was anion. After losing this is getting it. But like previous example, this is not the radical initiator. It will also undergo homolytic fission. This odd electron will come here. This odd electron will come here. This will give up minus carbon dioxide, and your free radical will be R from this. R free radical is formed, and this R and any other free radical can combine with other free radical. So this is how electrolyte. In this also we can take mistake that this is the free radical or this. No, this is anion. Anion forms at anode. At anode oxidation takes place, and hence free radical is formed at anode. This free radical will be formed at anode. Similarly, see, one more very good source of free radical is N-bromosuccinimide. I hope all of you remember N-bromosuccinimide. Now, N-bromosuccinimide is this. This is succinic acid. Succinimide, H replaced by B. This is NBS. Now, NBS is a reagent which gives us bromine very slowly, and it is specific for, this reagent is specific for allylic bromination or sometimes benzylic bromination. Benzylic bromination. This reagent is N-bromosuccinimide. The N-bromosuccinimide will give us slowly, it will give us bromine free radical and bromine free radical, and it is very specific for whenever it is this. Say example we have written, say we are writing this example, this, and if it is NBS, NBS means of bromination will take place, but bromination will take place at this through free radical mechanism at allylic position, and allylic position is this. This is the answer, free radical formation of this. So this is how various examples for the formation of free radicals. These are the various ways. So important ways for the formation of free radicals are: free radicals will be formed by heat or light maximum tendency, or the very good initiator of free radicals are peroxides. So these are how free radicals are formed. Okay, we will continue from this, and in next lecture we will study about detailed example about stability of free radicals. Okay, thank you. Keep doing your work.